in this video we're going to talk about multiplying radicals. We're also going to talk about adding and subtracting radicals. But first, multiplying. So when you're multiplying radicals, if it's written in radical form, you can only multiply the radicals if the index is the same. So for example, if you had the square root of 17, you could easily multiply it times the square root of 19. All you would do is multiply 17 times 19 and then simplify it. However, if you had the square root of 17 times the cube root of 19, you could not multiply those because you have an index of 2 here and an index of 3 here. So you would not want to multiply those. So to do this, you have 3 easy steps. You multiply the coefficients. Remember, the coefficient when you're looking at radicals would be the number on the outside. So in this situation here, there was no coefficient, or it's 1, in which case you don't have to do anything. 2, multiply the radicand, the number under the radical. And then 3, simplify. Remember, look for any perfect squares or perfect cubes, whatever the case may be, based on your index, and pull them out. So let's look at a couple examples. So example 1. Okay, let's look at our steps. Multiply the coefficients. So 2 times 5, or 10. Go ahead and write our radicand, or radical sign, and then 3 times 2 is 6. So under here, 6 is not going to break down at all because it's just simply 2 times 3. So our answer in this case would be 10 square roots of 6, and we can leave it as that. And then here, 3 times 1, or 3, and then square roots of 8 times 2 is 16. Now, in this case, 16 is a perfect square of 4, so this becomes, because if we rewrote this, it would become 16 is 4 squared. That's a perfect square, so this actually becomes 12 when we simplify it. And if you missed how I did that, 16 is the square root of 4 squared. And when we took this out, when we pulled out the 4, this became 3 times 4. 4. Because remember, you pull out anything that has a perfect square in it, and 3 times 4 would simply give you 12. That was our simplify step. So multiplying radicals, again, multiply the coefficients, multiply the radicands, and then simplify. And it's this simplifying step here that sometimes catches people off. Okay, so let's take a look at adding and subtracting. Okay, so adding and subtracting radicals is just like combining like terms that you've done with algebraic expressions. So let's combine a few like terms from algebraic expressions just to refresh your memories. So remember, combining like terms, you have to have the same variables or lack of variables, whatever the case may be. So in this case, for example 1, 2x minus x is going to leave us with just 1x, and then plus 4x, this would give us 5x. Then if we go over here, we have 3y minus 2x plus y minus 6y. The x is going to stand alone, but we can combine all these y terms. 3y plus y gives us 4y minus 6y. It's going to give us minus 2y. And then this one, 7x plus 4y. There's nothing to combine with the 7x and nothing to combine with the 4y. So it's just going to remain exactly as it is. Okay, so let's replicate what we did here, only this time with radicals. So in this first one, we have 3 square roots of 3 plus 4 square roots of 3. And now what we want to be the same is both our index and the term that is under our radical sign. What's beside our radical or the coefficient does not matter. That's actually what we'll be combining. So it's kind of like fractions also. So we've got our square roots of 3, so we know that's going to be there. So it's what's on the outside. So 3 plus 4 is 7. So it equals 7 square roots of 3. So now we look here. 4 square roots of 12 and minus square root of 75. Don't brush this off and think nothing can be done, because you have to first look at these and think, are they simplified? Again, go back to your fraction knowledge. Do they have a least common multiple? Do they, have a common denominator? So 4 square roots of 12. This I know is not simplified because 12 I could break down to, let's see, 4 times 3, 2 times 2 would break down, and I would get 4 square roots of 12 can be rewritten as 4 times 2 square roots of 3, or 6 square roots of 3, because this was a 2 squared, and now 75 breaks down to 25 times 3, or 5 squared times 3, which means I'm going to have a 5 that comes out and a 3 left under it, and all of a sudden, look what I've done. I have rewritten this as a problem where what's left under my radical is the same number, and they do have something in common, and I've got my like terms. So now the problem I'm dealing with, instead of being 4 square roots of 12 minus the square root of 75, is actually 6 square roots of 3 minus 5 square roots of 3. And this is a problem I can easily solve. 6 minus 5 gives me 1, and my square root of 3 stays just like it was. So now I think you have some other problems in your notes. Why don't you try and work with those, and we will look at them tomorrow in class.